You felt the first sign 3 days ago and you dismissed it. A tightness in your jaw. The kind of stiffness you'd get after a long dental appointment or from clenching your teeth in your sleep. You figured you slept on it wrong. You took some ibuprofen. You moved on with your day. But this morning you woke up and your jaw would not open. Not it's sore. Not it's a little stuck. It will not open. The muscles that hinge your mouth have contracted into something like stone, and no amount of willpower is moving them. And nothing hurt you. There was no big injury, just a small puncture on the bottom of your foot from a week ago, from a nail, from a splinter, from a moment you already forgot. That tiny wound is the reason your jaw is now welded shut. And in the next few hours, the same thing that locked your jaw is going to work its way down your neck, into your back, into the muscles that let you breathe. This is tetanus. And unlike almost every other way the human body can fail, this one lets you stay completely awake for all of it. Now, the cultural memory of tetanus is basically one image. A rusty nail, a shot, the end. The rust is a myth. It has nothing to do with the disease. The wound can be microscopic, the metal can be spotless, and the shot everyone pictures only works if it goes in before your jaw locks. After that, you've crossed into a completely different medical universe, and the one decision that decides whether you walk out of it is not what your instincts will scream at you to do. We'll come back to that. Let's rewind to that small wound. The culprit is a bacterium called Clostridium tetani, and it lives in soil and dust, basically everywhere outside. It survives in a dormant form called a spore, essentially a bacterium sealed inside a nearly indestructible capsule, waiting. Spores can sit in the ground for years. When one gets pushed into a deep, narrow wound, something specific happens. Deep punctures don't get much oxygen, and that's the entire point. Clostridium tetani is an anaerobic bacterium, meaning oxygen is toxic to it. It cannot grow in the open air of a scrape, but a deep puncture, sealed off from the surface, starved of oxygen, with a little dead tissue around it, that's paradise. The spore wakes up, starts multiplying, and begins manufacturing the actual weapon. That weapon is a protein called tetanospasmin, and its potency is what reframes the entire disease. Tetanospasmin is one of the most lethal substances known to biology. By weight, the estimated lethal dose is around 2.5 billionths of a gram per kilogram of body weight. In other words, the amount that could kill you is far too small to see, taste, or register in any way. The bacteria in your foot are producing a poison so concentrated that a rounding error's worth of it is a death sentence. And your immune system largely ignores it because there's so little of it and it moves so quietly. And that toxin doesn't spread through your blood looking for trouble. It does something far more deliberate. It finds the nearest nerve ending where your nerves connect to your muscles and climbs aboard. Your nerves are long cells, some running from your spinal cord to your foot in a single strand, and they have an internal transport system that moves cargo up and down their length, like a conveyor belt inside the cell. The toxin hijacks that conveyor belt. It rides your own nervous system backward, from the wound toward your spinal cord at a crawl of roughly a few millimeters to a centimeter a day. This is why the disease takes days to weeks to appear. The poison is literally commuting to your central nervous system, and it is in no hurry. What it does when it arrives comes down to one fact about your body. Your muscles are not designed to relax on their own. Left alone, your nerves want to fire and your muscles want to contract. What keeps you from being a rigid, cramping mess is a set of braking signals. Specialized nerve cells in your spinal cord constantly release chemical messengers, mainly two called GABA and glycine, and their entire job is to tell your muscles to ease off and relax. Think of them as the brake pedal on every muscle in your body. Every second of your life, those brakes are gently applied so your movement stays smooth. You never think about it. It just runs in the background. Tetanospasmin's one and only trick is to cut the brake lines. When it reaches your spinal cord, it slips into those braking nerve cells and destroys the machinery they use to release GABA and glycine. The brakes don't fail all at once. They fail one by one, and there's no way to reapply them. The chemical signal that says relax simply stops being sent. Which means every muscle those nerves control now gets only one message, forever. Contract. Harder, and never let go. The jaw goes first because those nerves are short and the toxin's effect shows up there early. This is the lockjaw, the symptom the disease is named for, medically called trismus. Your masseter muscles, the thick muscles on the sides of your jaw that you can feel bulge when you clench, are among the strongest in your body for their size. And now they are contracting with nothing to stop them. That's the stone jaw you woke up with. Then it spreads to your face. The muscles around your mouth and eyes pull tight and lock, dragging your expression into something that looks disturbingly like a strained smile. This has a name that's been around for centuries, risus sardonicus, the sardonic grin. It is not a smile. It is your face being pulled into the shape of one and held there against your will, and you can feel every second of it. And this is what makes tetanus uniquely cruel among the ways a body can shut down. Your brain is untouched. The toxin attacks the wiring in your spinal cord, not the part of you that thinks and feels and knows. So you are fully, completely conscious. Your mind is clear. You understand exactly what is happening to you. You can feel each muscle group as it seizes, and you experience all of it as intense, sustained pain with no fog, no confusion, no merciful dimming of the lights. In most catastrophic ways to die, the brain checks out early and spares you the worst of it. Tetanus does the opposite. It keeps you present for the entire performance. From your face, the rigidity marches down, your neck stiffens, your shoulders, then your back, and this is where the disease shows its raw physical power. The long muscles running along your spine are far stronger than the muscles on the front of your body. So when everything contracts at once, the back muscles win. Your body arches backward. In severe cases, the spine bows so hard that a person rests on their heels and the back of their head, the rest of the body lifted off the bed. Doctors call this tetanus. These are among the most forceful contractions the human body is capable of producing, and they are strong enough, in documented cases, to crack the vertebrae in the spine or tear muscle away from bone. Your body is, in the most literal sense, generating more force than its own frame can safely contain. And now it gets worse because up to this point the contractions were constant, but at least steady. Then the spasms start. Any trigger at all, a sound, a bright light, a door closing, a hand on your shoulder, a draft of cold air, sends your entire body into a violent, whole-body clench that can last minutes, every muscle firing simultaneously. During these episodes, you can't speak and you can barely breathe. And again, you are awake for all of it, feeling each one arrive and having no way to stop it, knowing the next one could come from something as small as someone whispering in the hallway. Which brings us to the mechanism that actually ends it. Your diaphragm, a dome of muscle under your lungs, powers every breath you take. When it contracts, it pulls air in. You also have muscles between your ribs and a narrow ring of muscle around your vocal cords at the top of your windpipe that opens and closes your airway. Tetanus spares none of these. When the toxin reaches the nerves controlling your breathing, those muscles lock and spasm like all the others. The ring of muscle around your airway can clamp shut, a laryngospasm, sealing off air completely. Or your chest and diaphragm seize so hard they can't move air at all. Either way, the outcome is the same. The one system you cannot live without stops working. Not because your lungs are damaged, but because the muscles that operate them have been ordered to contract and can no longer let go. Death from tetanus is, at its core, respiratory failure. Your breathing muscles lock, and you can't draw air, while your mind cruelly may stay clear right up to the edge. Layered on top of that, the same broken braking system throws your autonomic nervous system, the automatic controls for your heart rate and blood pressure, into chaos. Your blood pressure swings wildly up and down, your heart races and then stumbles into dangerous rhythms, you sweat profusely and run a fever, and your cardiovascular system can give out entirely from the strain. Between the airway locking and the heart destabilizing, the body runs out of ways to keep itself running. And that is how it ends. This is not a sealed fate, and the decision that matters most is coming. Go back to New Year's Day, 1842, in Concord, Massachusetts. A young schoolteacher named John Thoreau, 27 years old, was stropping his straight razor, and he nicked the very tip of one finger. Barely a cut, skin deep, just enough to draw blood. He put the skin back down, wrapped it in a rag, and thought nothing of it. Anyone would have. For over a week, nothing. Then the wound turned dark and dead-looking, and days later his jaw began to stiffen. The lockjaw set in. A doctor was summoned from Boston, examined him, and concluded there was nothing anyone could do because in 1842, there was nothing anyone could do. There was no antitoxin, no ventilator, no intensive care. John Thoreau died on January 11th in the arms of his younger brother, and he kept his senses and his power of speech nearly to the end, which is exactly what tetanus does. That younger brother was Henry David Thoreau, who would go on to write Walden and become one of the most important voices in American literature. He was so shattered by watching his brother die this way that he developed the physical symptoms of lockjaw himself, purely from grief, before recovering. So here is how you survive it, because unlike John Thoreau, you have 2 centuries of medicine on your side, and the odds today are dramatically in your favor if you act correctly. The single most important thing is timing, and the decision that matters most is this: you go get help the moment you suspect tetanus, not the moment it becomes undeniable. The antitoxin, a preparation of ready-made antibodies called tetanus immune globulin, can only neutralize toxin that is still floating free in your body. Once the toxin has locked onto your nerves, no antibody can pull it back off. So every hour you wait, more of the poison binds permanently, and less of it is reachable. The people who do well are the ones who show up early while there's still free toxin to mop up. That first stiffness in the jaw, that vague tightness you want to explain away, that is your window, and it is closing. Do not wait to see if it gets better. It will not get better on its own. At the hospital, the response is aggressive, and it works. They clean out the wound thoroughly, cutting away the dead tissue, because that oxygen-starved pocket is the factory still pumping out toxin, And starving it of that environment shuts down production. They give you the antitoxin to neutralize whatever poison hasn't bound yet. They give you an antibiotic, usually metronidazole, to kill the remaining bacteria. And then, critically, they manage the symptoms while your body slowly clears the toxin over the coming weeks. They give you high doses of benzodiazepines, the same class of drug as Valium, and this is elegant because those drugs boost the exact braking signal, GABA, that the toxin was suppressing. They are, in effect, reconnecting the brake lines chemically while your nerves rebuild the machinery. In severe cases, they'll put you on a ventilator, sometimes after a tracheostomy, an opening in the windpipe, so a machine breathes for you and it no longer matters that your breathing muscles are locked. They'll keep you in a dark, quiet room because every sound and every light can trigger a spasm. And they'll ride out the storm with you. With modern intensive care, most people survive this. The toxin's grip is permanent on the nerves it's already bound, but nerves recover, new braking machinery gets built, and the body, given enough support, comes back. And there's the version where you never get here at all, which is the one you should actually want. The tetanus vaccine is one of the great quiet triumphs of modern medicine. It trains your immune system to recognize and destroy the toxin before it can ever reach your spine, and it is close to 100% effective. The only catch is that it fades, which is why you need a booster roughly every 10 years, and why that unglamorous shot they offer you after a dirty cut is not medical theater. It is the difference between an annoying afternoon in an urgent care and the fate of John Thoreau. Check when you had your last one. And if you can't remember, that's your answer. Subscribe